Discuss the important topic mechanics. What did you mean by the mechanics? You are well know that mechanics is only a study about the solid object. Solid object means there is no deformation and it will transfer 100% work into energy. Which kind of energy? Potential energy and kinetic energy. And the mechanics is also to study about the motion of the object. And motion of object is transfer when object is perfectly solid. And now we are discuss about the second thing, force. Force is an action of a body to transfer on another body to change the state of position, direction and point of application of their forces. So that is a very important characteristics of the forces. Now to change the direction. Second, point of application. And there are so many characteristics which are studied under the action of the forces. These are the characteristics of the forces which are change the position of any object. And let us discuss the derivation part of the force. Actually now this will coming from a Newton's second law. Force is now actually coming from Newton's second law, NSL. F is equals to rate of change of momentum per unit time. So this will simply write down in two parts. First, this is a differentiation form. Their mass and velocity without changes with respect to the time. So it will write down dv by dt and plus v dm by dt. And now this form of mass is to change in velocity and this is here change in mass. But in a mechanics, the change of mass is not considered. That's why this will consider to be zero. So in a solid mechanics, only the formula is now coming. F is equals to m into a. This is under the consideration of the real mechanics. And force, well know that force is a vector quantity. What did you mean by the vector? Vector is basically represent the position of an object which is moved in multi-direction. So their characteristics will confined with the help of vector. For example, let us will take the one example which are shown by the position of the vectors. Like any object which is starting the journey from point O to a point P, any point P, and which are at a certain angle theta. So their positions has to be defined with respect to two directions. One is along the x-axis, and this vector representation of the x-axis, it is the direction of the unit vector x, and here this is a y-axis and its a vector representation is a j cap. Now this object which are situated at a point P, their positions will be defined in form of OP vector. How it will write down? First, OP has a two component. One is a horizontal and another one is a vertical component. So here write down OP cos theta, and now in the vertical direction OP sin theta. So how it will write down? The position vector of the OP of any moving particle which are starting the journey from point O to P is write down OP cos theta I cap plus OP sin theta j cap. This is a position vector. An object they are moving along with x and y axis. So that is the concept of the vector. Vector is a represent the direction, multi-direction of any object. Now the last thing which I will discuss, Lami's theorem, which are very helpful to resolve a very complex problem when forces they are acting on a body. Lami's theorem. Lami's theorem is basically state that if three forces they are in equilibrium, acting on a body, then ratio of ratios of two forces is directly proportional to the sine of angle opposite of two forces. So that is the Lami's theorem. These are actually based on the equilibrium condition of the three forces. They are acting at a certain points, and the ratio of two forces is directly proportional to the sine of angle opposite of the two forces. How it will write down graphically? So this is a very simple and very easier concept to resolve the forces, multi forces they are acting on a body. Like this is a force A, this is a force B, and this is a force C. And the angle of this force is alpha, this is beta, this is gamma. A, B and C. These are the forces and which are acting at the point of application at point P. So these forces how to write down and how to calculate in the ratios form. First, this is my force A. This is the direction of the force A and I will take the sine of angle alpha because alpha has a two opposite side of these forces. A upon sine alpha is equals to, like a similar fashion, B, this is the direction of the forces and it will take the opposite angle between the two forces, B upon sine beta. And similarly also the C component of the force is also write down the opposite of the sine angle C is equals to sine gamma. So this is the basically Lami's theorem which are very helpful to calculate any complex problem when more than two forces they are acting on a body at a equilibrium position. So this will calculate right now. Now the last thing I will discuss application of the Lami's theorem. For example, this is a wall and this is a two pivoted point and where two pulleys they are aligned in such a manner and on the one side 10 Newton weight they are keeping down and on the other side 40 Newton weight they are acting towards the downward and here also 50 Newton force or mass they are hanging at a position P. So how to apply the Lami's theorem here? Because I will calculate now at a position P. If this mass has to pulling downward, so their tension will apply here simultaneously. And now I will bifurcate this point. This is the point of application is about P. And I will make a angle theta and theta. So how to apply separately the Lami's theorem? Lami's theorem is saying now three forces they are acting at a certain point and this angle is what? Theta and theta. And this will write down in the form of Lami's theorem first and then I will calculate the simply tension the each wheels on the string through the strings which are on the one side hanging a 10 Newton and other side they are hanging a 40 Newton weight and this is the tension which are applied through the strings because the 50 Newton force they are pulling this body. So how it will write down here apply the Lami's theorem at a point of application point P. At point P is apply the Lami's theorem T. This is the tension on the one side and the to take in angle between two opposite sides. Angle between two opposite sides. So here the theta and the rest of them is 180 minus theta. So tension is write down sine of angle 180 minus theta. And now the second tension of the second side T and also to take in opposite of the angle sine 180 minus theta. And the third force 50 Newton they are acting and the opposite angle is sine 2 theta. So like that 50 upon sine 2 theta. So that is a balanced equation of the Lami's theorem, and which are very help us to resolve the three forces which are acting at a certain points. So that is called what? Lami's theorem. And the last thing which are very helpful to calculate the relation between force, mass, acceleration, rate of change of momentum, and so on. That means these are the properties of the motion characteristics. Motion characteristics like time, velocity, speed, acceleration, force, momentum, that means torque. These are the motion characteristics or the motion parameters which will directly confine the motion. And motion is generally two kinds, linear, and second one is a rotational. The 90% useful work they are produced by the rotational motion like a wheel. They are also help us in our daily life like automobile sector. They are generally making a wheel and also to making a gear. So these are the basically based on the rotational motion. Linear motion is also used, but rotational is a 90% used in your daily life. So the last concept of the acceleration and force I will discuss today here. Force, mass, and acceleration. And what is the another form of the acceleration? We will write down v dv by ds, and that is a IRT. They are generally asking this type of questions from this formula. Acceleration is dependent, how much velocity is dependent on distance. So directly put it v dv upon ds. So another very important relation, IIT recent years they are frequently asked this type of question. In this question, acceleration is directly towards function of the velocity to the distance. That's okay.